comparison tests. And number 3, I made a mistake, and it's really dumb because my mistake is in the very first step with what I was comparing to. Do you see how I compared with this denominator being n to the third? Do you see how there's an n in the numerator? So if you have n to the first over n to the third, one of the n's is going to divide out. So instead of a 3, what should this be? A 2. Okay, so we're not going to have to redo very much. We're going to just have that trickle down. So that's a 2. I compared to the wrong thing. All right. That's going to make that a 2. This will still be infinity because this is still exponential and this is still polynomial. Exponential grows faster than polynomial. So this is still going to go to infinity and diverge. And again, a comparison test is like, hey, look over there. Since that one diverged, we want to say this one does too. Okay, like since that one did this and the one we're comparing to, and they're similar enough, we're going to say this one does too. So as long as your limit is finite and positive, then you can say, hey, they do the same thing. So I'm going to change this to a 2. Again, that was my little error. And so this is going to be a 2. I'm just erasing that and fixing it everywhere. And then when you go to do this limit, do you see in the numerator you have n and then n squared? When you multiply that, that would be n cubed. In the denominator, we also have n cubed. So you use your coefficients, which is going to come out to be 1/4. Since that is positive and finite, whatever the one we compared to does, this one does as well. So our big conclusion, like what we wrote with these other ones, it's going to be diverges by limit comparison. So we did a direct comparison and we did a limit comparison. Those are the 2 tests that we did last time. So if you were absent, that video exists, and you'll need to just make up the classwork for it. Organize myself of all the tests we've done so far. Let's just see if you guys can do them verbally. I'm going to check them off as you say them, and we'll do a quick recap. Nth term test. Now that is only for divergence. If you get 0, it's no conclusion. You're back to the drawing board. All right, what else? P series. P has to be greater than 1. Cool. For it to converge. All right. Geometric. R has to be less than 1. Good. You guys have got that. That was a bit shaky last week, but I told you you had some time. All right, cool. What else we got? Telescoping. If that second piece is finite, that means it's going to converge. It's not going to keep getting bigger. It's not going to telescope outwards. It's going to telescope downwards, and it'll converge. What else we got? Integral test. If the integral converges, so does the series, but not to that same number. The series will be bigger. Good job. All right, cool. We got 3 more. Okay, so the comparison is really 2. Direct comparison and limit comparison. And then we got 1 more. Alternating series test. The series has to alternate. The limit to infinity has to equal 0, and the terms have to keep getting smaller. And we're going to close the computers. I'm starting the lesson now. If none of those work, the ratio test is your Hail Mary. Like, hey, nothing else works. This is my last ditch effort to see if I can get something to converge or diverge, or tell whether something converges or diverges. Okay, so this is the last one. No, as you'll see. So if you do this limit, and I'm going to show you, it's going to be a little bit of writing, but it's not hard. You're going to end up writing the same thing over and over again. So you just have to stay organized, okay? If you do this limit, which I'll show you how to do, if it comes out less than 1, converges, greater than 1 or goes to infinity, obviously diverges. If it equals 1, that's no conclusion, and that's where the test fails, and you have to come up with a different test. But hopefully you figured out something else before that. I have one like that on here, okay? So let's go ahead and write our limit. We're going to do limit as n goes to infinity. And again, fine print here. You're going to do a little bit of writing, but it's not hard. I actually really like this test. You end up writing the same stuff over and over again, and then things cancel out. Now we're going to put this gigantic absolute value bar, and I'll show you how I do this. It helps me stay organized. Everyone's brain works differently, so you can kind of do what you want to do, but I'll show you how it works in my mind. Now, do you see how in the numerator it says a sub n plus 1? All you're going to do is for your series, everywhere there is an n, you're going to replace it with n plus 1. Good. Okay, cool. So this is going to be 2 to the power n plus 1 over n plus 1 factorial. Now, that is over like the series. So here's how I do this. And again, you can kind of do what works best for you. When I put it over the series, I make my fraction bar connect to the absolute value. It helps me in my mind separate which one is which. Does that make sense? Like, I don't know, if you don't want to do that, you don't have to, but I just feel like it ends up looking like a lot. And then basically you just copy this over. So 2 to the n over n factorial. You may at some point get comfortable enough with this that you skip that first step and go ahead and do the reciprocal, because you know, if you divide by a fraction, you multiply by reciprocal. And if you want to skip straight to this step, I will go ahead and tell you, I never, ever, 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 ever do that. My brain struggles. I write everything. Okay. And it is not an intelligence thing. Like, oh, I'm smarter because I can skip that step. No, that's not how that works. Everyone thinks differently. All right. But we're going to change this to multiplication, and I'm going to reciprocate. We're going to flip this over. So n factorial over 2 to the n. Now, after that step, we're going to get some things to cancel out. And I'm going to stop there because I know it's a lot to write, and I'm going to let everybody catch up. But do you see how we kind of just wrote the same thing twice? Yeah. Okay. So it is a little bit of writing, but this often shows up on the free response part of the exam, and I really love it because it's just very procedural. And you just go through and get your answers. So I kind of like when it shows up because usually you can get all the points and it's worth a lot. All right, so let's look at the 2's first. This is 2 to the n plus 1, and this is 2 to the n. For example, let's make up a number like 7. Say you had 2 to the 7th. That would be 2 times 2 times 2 times 2, 7 times. You get what I'm saying? All right, and then this would be 2 to the 6th. You would have 2 times 2 times 2, 6 times. So all the 2's would divide out except for 1, and it would be left where? On top. Okay, so I'm going to have a 2 left up here. That takes care of these 2 parts. Now let's think about the factorials. If you had 7 factorial, it's 7 times 6 times 5 times 4 times 3 times, okay? And then I just made up 7. I just used that as an example. Then this would be 8 factorial, would be 8 times 7 times 6 times, blah, 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 blah. Okay, so the 7 times 6 times 5, all those would cancel out. You'd be left with just the n plus 1 on the denominator. You'll get used to it, like, as the more you do, the easier it'll get, like anything else in the world. All right, now we're going to evaluate the limit. As n gets bigger and bigger, the denominator gets larger and larger, and so this goes to 0, which is less than 1. So your big conclusion is converges by ratio test. We're just going to try that a few more times. That's kind of all it is. It's very procedural. It's just a little bit of writing. Okay? So let's see for this one. We're going to do limit as n goes to infinity, gigantic absolute value. And what you're going to do is everywhere you see an n, you're going to replace it with n plus 1. Now, when you get to that second part there, do you see how it's already 2 to the n plus 1? It would be n plus 1 plus 1. So n plus 2 over 3 to the n plus 1. And again, you can kind of do what works best for you. But when I draw that fraction bar, I make it connect to the absolute value. It just helps me separate in my mind, like, what is what. And then down here, you're just going to copy the original series. And so again, you're going to multiply by the reciprocal. I'm not going to talk through that because that's just going to be annoying. But basically, can everybody just recopy the first part, change it to multiplication, and then flip this one over? And then we'll start looking at what cancels out or divides out. And so if this does show up on your free response, first of all, I'm happy about that because I feel like you can get all the points. So as you're writing all of this, I just want you to think like points, points, points. I'm getting points for doing all this. It's usually worth 4 or 5 to do a ratio test. And I feel like it's pretty straightforward. You're just kind of doing a lot of writing. They're rewarding you for doing a lot of writing, but you do have to stay organized. That is a lot to look at. And if you mess up something or do a copy error, then it's going to fall apart. As you saw that I made a mistake last time. So, I mean, it happens. All right, so let's try and do these one by one, see what's going to cancel out. Let me do the 3's first. We're going to have 1 3 left, and it's going to be on the denominator. Do you see that? Okay, so we're going to have a 3 here that takes care of these 2. Oh, yes, thank you. Good save. I'm going to need to go down to the next line. It's not going to fit when I have to write limit in front of it. I got so excited to cancel everything out, I forgot to write limit. Okay, so we're going to have 1 3 left. It's going to be on the bottom. Then I would do the 2's. So this is 2 to the n plus 2. This is 2 to the n plus 1. So again, you're going to have 1 2 left, and it's going to be on top. Now, these are not going to divide out. So in the numerator, you've just got that n plus 1 squared, and on the denominator, you've got just n squared. They are both squared. When your powers are the same, you use coefficients. So this limit goes to 2/3, which is less than 1, converges by ratio test. Go ahead. Where are you saying you would stop? Like, are you saying you wouldn't write this?
Well, I think after you write, like, if you were to just write maybe not up there, right? After multiplying them, without simplifying.
What I've written here is good enough.
Okay.
I probably wouldn't write less than that. And if you are mentally comfortable skipping this first step, don't do that if this shows up on the free response part. Write everything, okay? Okay? Like, don't skip to here. You want to do the setup, just in case. I would hate for them to not give you the points. I mean, I would give it to you. This is why I'm not a grader. Do you guys want to try this one on your own? And I got this. What did you get kind of situation?
I think I could.
Want to give it a shot? Okay. I'm going to pause the recording. All right, if you were watching from home, that sort of magically just showed up, you can pause the recording. All right, so let's see if we can cancel some of these things out. I would do the 5's first. You're going to have 1 5 left, and it's going to be on the denominator. Good. And then you're going to have what left in the numerator? Yeah, just n plus 1. If you get stuck on that, think of actual numbers. Like if this was 7 factorial, this would be 6 factorial. So the 6 times 5 times 4 times 3 times 2 times 1 all cancels. All you're left with is that 7. You're just left with that n plus 1. And then you're going to evaluate the limit. As this goes to infinity, the numerator is going to get bigger and bigger and bigger and bigger. So it's going to go to infinity. And so your big conclusion to the whole thing diverges by ratio test.
Wow.
Yeah, just a little bit. Well, some infinities are larger than other infinities. Go ahead. Yeah. Or infinity to the 0 power. What's that? For this one, let's have a quick conversation. We can try a ratio test if you want, but my hope is you wouldn't do that. If you do a ratio test, it is going to come out to equal 1. Just, I'm telling you, it will. And then it's going to say, no conclusion. You're going to have to try something else. So what kind of series is this? It's alternating. Okay, so let's do an alternating series test. Again, ratio test is like your Hail Mary. You hopefully tried everything else before you got to that. I would look at this and go, okay, alternating. So for your alternating series test, we're going to do limit as n goes to infinity for the series, the absolute value of it. So you don't need to include that -1. Square root is to what power? That's 1/2. This is to the first. So the numerator is smaller than the denominator. And so it is going to go to 0. And then what's the other thing you have to show for alternating series? Yes, the terms are getting smaller. So the n plus 1th term is smaller than, you kind of said the whole thing. So if you plug in n plus 1, denominator would then be n plus 2, n plus 1 plus 1. That has to be smaller than this, which it is. If you're interested and you want to plug in 1 and test it out, or plug in 2 or 3 or 4 and test it out, it is true. And so then your big conclusion is converges by alternating series test. So again, you don't want to jump straight to ratio test. It is your last resort. So if you see something's alternating or a p-series, or you can do a really simple comparison, do that. Ratio test is like, I'm out of options.
On the quiz, if we didn't put 4 in the
I didn't take off for that. Again, this is why I've always been asked, Ms. Cole, why aren't you a grader for the AP exam? I would be such a bad grader because I'd be like, hey, you tried. You know what I mean? Like, and I would be fired so quickly. Yes. You don't have to write that it's alternating, though. That's sort of, I mean, that's implied with this -1 to the end. All right, this is not going to have, this is not alternating. It's not a p-series. It's not geometric. It's not telescoping. There's not an easy thing to compare it to. Like that whole list that we made, none of that's going to work. So that's where your ratio test comes in. Oftentimes, ratio tests will have a factorial in them. That's how if you're like, I don't know when to do a ratio test. If you see a factorial, likely a ratio test is going to be good. All right, so if you plug in n plus 1, it would be n plus 3. And then over n plus 1 factorial, and then that is all over just, yeah, that. And then we're going to flip it over. Sorry, I wrote that as fast as I could so that I could move my hand and you could all see it. You don't have to write as fast as me. I know I write fast and talk fast, so it's a constant thing I need to be working on. I do try to get it written faster than you, though, again, so that you can see it. All right, so let's see if we can get anything to divide out here. Let's do, well, the n plus 3 and the n plus 2, there's nothing we can do with that. But with the factorials, we're going to have an n plus 1 left over, and it's going to be on the bottom. All right, so down here, that's an n plus 1. That takes care of these. The n plus 3 and the n plus 2 are, we're stuck with those. That's, nothing's going to work with that. Sorry, I closed it because it was raining. Now, if we go to evaluate the limit, this is n to the first. If you multiply these together, that is n squared, n to the second. So the numerator is smaller than the denominator. So it's 0, which is less than 1, and so your big conclusion is converges by ratio test. So we have finished all the tests. There's one more lesson. It's on whether something converges absolutely or conditionally, so it's sort of just a vocabulary thing, but you've learned all the tests. Doesn't that feel good? Like you did it. Because I told you there was going to be a lot of them. You got through it. Good job.
Oh, yeah,